during the Inquisition for that belief, and Galileo recanted. He was smart enough to recant his view, but was under house arrest for all of his life, his later life, because of his belief that the Earth is not the center of the universe. That's how deeply we are fooled by our perceptions. What I'm saying is that we had to give up flat Earth, we had to give up the geocentric universe. Those were just warm-ups. Now what we have to give up is the very notion that our perceptions of space and time and physical objects themselves reflect reality. Right? So we're being fooled by space and time and physical objects just like we were fooled about flat Earth and the geocentric universe. Only now we have to give up all of our perceptions as reflecting reality, not just a little bit here and there. And this has implications as well for the main topic of this conference, which is how is consciousness related to the body, the mind-body problem. And the reason it has an implication for that is most theories of the mind-body problem assume that the physical world, including neurons, exists independently of perception, that that's the objective reality. And as a result, they try to take neurons as the starting point for theoretical accounts of consciousness. And what I'm saying is, neurons are just a species-specific symbol. They're not the reality. One implication of this whole theory is that neural activity causes nothing. Because just like, for example, if I take the icon on the desktop and I drag it to the trash can, it looks like the movement of the icon to the trash can caused the file to be deleted. But that's just a useful fiction. Actually, there's no feedback from the screen to the computer. It's a useful fiction on the interface to think that physical objects have causal powers, but it's false. And so neural activity causes nothing. I do, by the way, I've published fMRI and EEG studies, so I do neuroscience, but I have to reinterpret the data in a different way. I don't take neurons as the fundamental reality. So as a result, the physicalist theories of consciousness are doomed to fail, and that's why we've made no progress. I mean, we've literally made no progress. It's called the hard problem of consciousness because we can't make progress that way. So most theorists today try to start with the physical and try to get consciousness coming out of it. I'm interested in the opposite, and I'll just at top level sketch the ideas. We won't have time to go into detail here. But the idea is to start with a very simple formalism. The tip from Turing is that Alan Turing decided to give a theory of what is computation, and he came up with this really simple formalism, a little machine that has a finite set of states, finite set of symbols, some simple transition rules, and it turned out he could prove that any computation could be done by this simple little device called a Turing machine. And that was what launched the theory of computation, computer science. So the idea is, can we do the same thing for consciousness? Can we come up with a simple formalism which will handle all aspects of consciousness? And maybe we can't, but it's worth a try. And so I'm going to give you my intuitions, and the idea is to have a rigorous formalism so that we can find out, where it's wrong. So if we're absolutely explicit, we can see explicitly where we're wrong. So the idea is that consciousness certainly has experiences involved in it, qualia, as they're called, colors and pains and emotions and so forth. We also have the ability to make decisions, actions, take actions. And those will affect the world, whatever the world is. And the world then will affect our experiences. And we can just translate this then into some mathematical symbols. We have a world W, experiences X, and actions G. And the idea is there's a map. I can go into math, it's a Markovian kernel, a perception map, a decision map, and an action map, and an integer counter to count the number of perceptions that you have. And this can be all cashed out mathematically in a different talk. But the idea is a conscious agent is just a sextuple. X, G, P, D, A, and N. So and then the claim is that well, I'll just say those are probability spaces. This is technical stuff. I'll just leave it for the moment. So here's the claim. Every conscious entity and activity can be modeled by conscious agents. So it's a very clear claim. It could be clearly false. Maybe someone will show that it's false, but the idea is this. I claim this formalism and networks of conscious agents, as I'll show you briefly, can handle all aspects of consciousness and personal experience. So one hypothesis then about the world is, instead of taking the world to be a physical reality, space and time and physical objects, matter and so forth, I take that stuff to be just our desktop, a species-specific desktop, and let's see what happens if we say that the real reality is just consciousness, conscious agents in interaction. That's the conscious realism. So the idea is that it's an ontology. Consciousness is the fundamental. Now we can have, if we have two conscious agents, we can make, so here they are, agent 1 and agent 2, we can actually take one of these agents and connect it to the other. So what I've done is I've taken one agent, and where the world symbol was, I've plugged the other agent in, because that's the conscious realism hypothesis. The world consists of conscious agents. So what you see is not space and time and physical stuff. It's other conscious agents, and your interface is just presenting you that interaction in space as a space-time desktop. So you can actually have conscious agents, they're linked in a network like this. You can do it more abstractly, a graphical symbol like that, where effectively one is sending information to the other and receiving information. So information is flowing between the two. You can have 3 conscious agents linked together, or linked like that. You can have 4, and in fact, if you think about it, you can have any number of conscious agents linked together in a network, and now you have a very interesting dynamical systems thing. You can have introspection. It turns out if you have 2 conscious agents, the mathematics surprised me. It turns out 2 conscious agents interacting satisfy the definition of one conscious agent. They are also one conscious agent that's introspecting. So what comes out of this mathematics is a model of introspection that's completely rigorous. You can have, so now more abstractly, each dot is a conscious agent. Each link is a connection between conscious agents where they're communicating with each other. You can have arbitrary graphs of conscious agents, and it turns out to be a theorem that given any graph of conscious agents, any subset of the conscious agents constitute a new single conscious agent. Surprising result. So any subgraph is a conscious agent. So the claim then is that conscious agent networks, these networks of conscious agents, first, it's a theorem that they have the power of universal Turing machines, which means that anything that can be computed by your laptop can also be computed by a network of these conscious agents. They have complete computational power. As a result, all the models that we have of, for example, unconscious processing in cognitive neuroscience, Julia Mossbridge talked a lot about the unconscious processes. We have lots of models in cognitive science, mathematically precise models of unconscious processes. All of those models can be re-expressed in terms of the computations of networks of conscious agents, every one of them. Plus, consciousness itself can be modeled. And each consciousness model, a conscious agent network model, is itself a new conscious agent. So each one is like an object-oriented programming language, which is really quite nice. It's a new architecture for thinking about unconscious and conscious processes. Really quite striking. And it's a framework then for all cognitive science models. Now, just briefly, if I start with consciousness, I have to. Am I out of time? 6 minutes. Okay. If I'm going to solve the mind-body problem, I can assume that physics is fundamental, and then my burden is to get consciousness. Or, what I'm trying to do is the opposite. I assume consciousness is fundamental. Then, my burden is to show that all of physics comes out of it. Quantum mechanics and so forth comes out of this. And it does. So this is an abstract agent dynamics where it's a very simple, each agent can only see one bit of information, 0 or 1. And you can actually program up these things. This is 2 agents passing information back and forth, 0s or 1s. And it turns out that when you look at the long-term dynamics of these, you'll have to take my word on this. When you look at the long-term dynamics, the states of the 2 agents become entangled. You actually have an entanglement of this is the title of my talk. Conscious agents actually get entangled because they have different kinds of asymptotic long-term behaviors. And it turns out that when you look at that long-term behavior and write it down, so this is, the top was the conscious agent dynamics long-term behavior. And then if you write down the wave equation for the free particle in quantum mechanics, it's exactly the same equation. So we can actually read off, this is the non-relativistic case, you can actually read off a one-to-one mapping between non-relativistic quantum mechanics and this agent dynamics. And I won't go through it. This is the actual read-off of the equivalence between space and time and aspects of consciousness. And if you're interested, I've got a paper that has the details that we don't have time for. But you can even read off energy and momentum from this. Now, that's non-relativistic, and I'll close by the relativistic. I mean, the ultimate thing is we want to have a relativistic quantum theory falling out of a theory of consciousness. And the direction I'm going on that, and I'm starting to collaborate with Chris Fields and some others on this, is to actually take a system of 2 conscious agents, and it turns out it can be represented by something called a geometric algebra that I've written down there. And that geometric algebra is precisely the geometric algebra that describes the relativistic quantum free particle, massless particle. So the idea is that we can get space-time coming out of this, Dirac spinors, and ultimately, using Penrose twisters, maybe even quantum gravity. So the idea is that this program, for it to be successful, has to start with consciousness and give us all of quantum physics, and then we've solved the mind-body problem going the other way. So, yeah, I could take, so I'll stop with that and a couple of questions. Yes?
I have a question. Has any of your own personal... I'm just curious to hear if any of your own personal or contemplative practices have influenced how you've come up with this theory and modeled it and so on.
They have. It's an interesting back and forth between the scientific left hemisphere stuff, and I do meditate. I've meditated for more than a decade, and so the two go back and forth, the right hemisphere and left hemisphere talking to each other and trying to work this stuff out. All right, yeah. Yes?
How do you incorporate reflex action, in perception decision action, maybe that bypasses the conscious agent, and secondly, memory, memory capacity.
So reflex action, which is an unconscious process, the key thing to think about, you might say, well, look, if you say that consciousness is everything, well, what about unconscious processes? I mean, they're unconscious, so consciousness isn't everything. And the key point here is, if I'm looking at you, talking with you, your mental processes are unconscious to me, right? I assume you're conscious, but I'm not conscious of your conscious processes. But I'm wise enough to say, just because I'm not conscious of your processes, that doesn't mean you're unconscious, right? And you'd be pretty cross if I said because I can't see your conscious, you're unconscious. Same thing is true of my own unconscious processes. Just because I'm not conscious of them doesn't mean that somebody inside me isn't. So the idea that comes out of this is that I'm not just one conscious agent, I'm a whole infinite network. Those graphs I was showing you of conscious agents, and reflexes and memory come out of the interactions that perhaps I'm not aware of. So you have this distributed notion of consciousness. So I call that whole network of conscious agents my instantiation. We each have an instantiation, and we're only aware of some small part of that instantiation.